Lesson 54 is proportions. And proportions are similar to having rates equal to each other. You've done proportions in the past. This should be just a review of that, not anything difficult. But proportions are when you have a fraction or a ratio or rate equal to another fraction, ratio, or rate. Okay? So what are proportions? A ratio equal to another ratio, or a fraction equal to another fraction, or any of those.
Oh, wait,
What is a ratio? Raise your hand, please. Trenton?
Oh, no, never mind.
Laney?
Okay, isn't it like that thing where it's like, it's a story problem, and then they had like 4 and then a 3 somewhere in there, so you put 4 over 3 and it equals 3 over 4.
And those are, that's actually, we call those rates, but they do create ratios too. We've been calling them rate problems, but it's when you have some value to another value, okay?
Oh.
And that's what you were saying. Jonathan, did you have another way of? No? Okay. What is the base here? Well, actually, let me take this backward. The ratio is the prefix of the word rational. What are rational numbers? From test prep?
Normal.
Rational numbers are normal numbers, but there's a specific definition for rational. Irrational numbers are square roots of values that don't work out. Pi, those types of things. Rational numbers are numbers that we can write as fractions. Okay, so rational numbers are numbers we can write as fractions. So ratio includes that. A ratio is a number you can write as a fraction. Okay, and that's why we've been writing our rates as fractions. So the word rate, ratio, and even fraction are all interchangeable.
What's a ratio again?
Ratio is a number you can write as a fraction.
You can write as a, are you going to our game tonight?
I doubt it.
You should.
What?
You should come watch the boys.
So here is the situation, Dakota, without being rude next time. We have a ratio equal to a ratio. You have a fraction equal to a fraction. When we did our Cuba problem, when I showed you the circles of Cuba, and we talked about the fractions, and we reduced them, and we expanded them, and that those fractions end up being 1/2 is equal to 4/8. They have the same value, they just look differently. Well, that's what this is set up as too. 20 over 15 is equal to 4 over x. Yes?
Oh, I was just going to say how to do it.
Okay, how would you work this, Trenton?
20 divided by 4 equals 5. 15.
20 divided by 4 equals 5.
So you divide 15 divided by 4.
I do it a little different order, but that still works what you did. Yes, Brittany?
You would take 4 times 15 divided by 20.
Okay, what was there a name that Mrs. Jackman gave to you last year for this?
I don't even remember doing this. I'm pretty sure I was bad at it though.
It's it looks like the Trojan swing, but it's not because the equal sign is between it. Okay? I call this, and Mrs. Arneson calls this, the butterfly method.
Well, that's pretty.
Okay? Does that ring a bell?
No. Nope.
Okay, so the butterfly method, one of the rules about a proportion is that the cross products are equal. Meaning if you take, like we do in the Trojan swing, swinging from the left, swinging from right, those products are equal. So if I take 20 and multiply it times its cross value of x, 20x is equal to the cross product of the other, meaning 15 times 4, and 15 times 4 is 60. My fault, I forgot the x. So 20 times x is 20x, and that equals 15 times 4, which is 60. Then we have it in a form we can solve. Most of you can see that x would equal 3, but to solve it algebraically, we would take and divide by 20. Divide by 20, x equals 3. So you're going to hear me call that the butterfly method. Cross
then
products are equal. Yes, ma'am.
you just take 15 times 4 divided by 20 then?
That's right. That's the process.
Okay.
That's what will be.
So
And
you don't mark
if
anything out
the
or
4 was
reduce
on the
anything?
bottom, instead
You
of on
can
the
just
top,
gotta
you
keep
take
it
20.
simple.
One thing at a time. Raise your hands, please. Go ahead, Isaiah. Finish up.
And if the 4 was on the bottom, then you can take 20 times 4 divided by 15.
Correct. If you had those inverted. Dakota.
Oh, so you don't like reduce anything?
Exactly. Good question or good point or whatever you want to say about it. What we have between these two ratios is an equal sign. We don't have multiplication, so we cannot reduce anything over here with something over here. Now, could you reduce your 20 and 15 before you started? Yes, you technically could if you wanted. And it would actually work out nice and neat for you, because if you reduce each by 5, that would be 4 over 3. So what would x have to be? 3. So on that one, if you just worked it out, you reduce that down, it would show you that. But I need you to know how to do it with the cross product, because most of the time it's not going to work out. You're going to need to be able to do that. Yes?
So you don't want us to do it that way.
I'd rather you do it the way I showed you. I was just showing, in case he was asking about reducing these two, that
12 divided by
you can reduce those. If it shows up like this, well then, you know x has to be 3. If it doesn't, you need to know how to do it using
So
the butterfly
then you
method.
don't want us
Raise your
to
hand,
take,
please.
Oh.
Laney.
So then you don't want us to take 15 times 4 divided by 20?
You do, but he doesn't want you to reduce it before you do all that work.
No, that's not what I'm saying either.
You can't reduce
What I am saying, and we will say this into the mic one time here. If you see this and reduce it, as I did, it gives you 4 over 3 equals 4 over x, so x would have to be 3. What I'm saying is, if you reduce this down and it didn't work out to where it equaled this nice and neat, then you would take that butterfly at that point, butterfly method. So
if you just don't reduce, then you can do it normal.
you can just go straight to it without reducing. You don't have to reduce, but if you do, it could give you this, but not very often is it going to work out nice and neat.
Okay.
It's most of the time going to give you a fraction like this one. We can't reduce 4/5 down. It's got to stay 4/5. So we have to use the butterfly method to solve.
28.
So that's 5p equals 4 times 7 is 28. And so then we divide by 5.
5.6.
But we can't, or we're not going to, excuse me, we're not going to write it as a decimal. We're going to leave it as a fraction because the problem starts as fractions. So when if you divide by a number that it won't reduce by or whatever, then that's just the answer. 28/5. It won't reduce, so there's your answer. Earlier Trenton said something about taking 7 divided by 5 and multiply by 4. That process works, but if the numbers don't work out nice and neat, then you're caught in a mess.
If they do work out.
Yeah. Alright, so now evaluating, going to the next thing here, evaluating values when we're missing both the variable and the exponent. If we're missing both parts, we always plug in the value part with parentheses. So 4, and then we can put the exponent in without a parentheses. 4 to the third. All of us know that 4 to the third is now what class?
64.
64. All one of us knows that that's 64. Don't we? Alright, the cube, Q is 64,
It'd be 3 or 4.
and then P is 3, so the cube root of 64 is
4.
4.
4.
Is that it? That is it. I wanted to have you, just on your notes there, let's do a couple more of those proportions so you practice before I send you on your way.
Send us in the real world.
That's right.
I love that show.
Oh yeah, they're always getting fat.
The real
Go
one?
to bar.
Is that 5 over 5?
Get drunk.
You failed. It's overread.
Can we just put X's?
You can when you're doing your problems, that's fine. Alright, so solve this real quick just on paper here.
20 over 3.
Without saying it.
Wayne.
God.
You ruined it.
I do hope that these appear easy. They will obviously add to them by putting fractions to where you'll have fractions in your proportions, and we'll have to work those out and things, but it's just going to be the same process. So if we take a cross product through our butterfly method, we have 3s equals the product of 5 and 4, which is 20, divide by 3, s equals divide by 3, 20 over 3.
That was a 5.
That's why I rewrote it. It looked like 5 when I first wrote it. Yes.
That was a 5 at first.
You think that's an S, not a 5. So that's 5. Oh, this is an S, and that's a 3. So you have 3s, s, and you wrote x equals 20. What is this? Divided by 3. So you have to, if you're going to show it that way, you have to put both over 1, and then KFC. But you can just also write it. You can just go 3 that way, and that's showing the division. Would you put the can away, please? Thank you. Yes.
I don't like go back on the first.
No. You can get it after class. All right, your assignment is going to be 1 through 30. From set
1 through 30.
54, 1 through 30. It is due tomorrow. You have just shy of 30 minutes of class. You have a seminar time today, so you better get going if you don't want some work tonight. Good luck.
I'm gonna rage quit from this lobby. Like, we're gonna get her house and not the swamper. Can I get a drink, Mr. Clark?
We're gonna go sleep in the CAD car.
I got Twizzler.
No more candies.
No Rolos?
She won that from the teacher, though.
Religion teacher.
Hey, okay. Will you tell me if this is weird?
You brought it?
Here's what my religion teacher told me that was.
I had the prettiest sketch.
This was our drawing. They said I was the most dope.
You broke it!
I really did not mean that.
Believe it or
Dope
not.
meaning,
Swag.
yeah, it's that.
Okay, because my Jesus had a pimp hat and he was like, welcome to heaven.
Mine was
My Jesus was a stick figure, and I
Mine
got
was
prettiest
most
sketch.
Shania.
It's Clevenger, believe it or not. I was the runner-up for the most quiet.
I believe that. Until the last 2 weeks, you've been super quiet for me.
Yeah, you just think
Last 2 weeks, all of a sudden, you become Cheddar Man.
Yeah, man.
Is there a reason?
And the most sketch and drawing. I also got that one.
Which religion? Like
St.
which
Michael's.
church?
St.
St.
Michael's.
Michael's. So who is your teacher?
Well, it
Well, our
was-
teachers had to quit because they adopted a kid because they couldn't have me, I think. And so.
Well, they got a child from the team, and so it just was kind of scary.
Jake was the most quiet. He got almost kicked out of class.
No. Yeah, I almost got kicked out twice. Austin was
Isaiah?
the most quiet.
Do not speak of Isaiah.
No, I mean, Austin was the most quiet.
Our teacher sent me and Jake
I
Aaron.
am the most quiet.
Well, when Father taught our class,
No.
Isaiah had to go in the corner.
So did Jake.
Yeah, I got put in the corner.
Thanks for the information.
Oh,
Any
It's
attention,
still
Can I
Jake?
talk about how I
recording.
almost got a
Tell me real quick so you get it out.
I was rubbing my feet on the ground after they waxed the floor, and it was really squeaky. And Mr. Obedi got mad at me, and he just gave me a really.
So he almost got it.
He almost did, but he didn't. I was trying to.
You're doing it on purpose to
Yeah.
be a distraction. I think.
What
I
is
would-
boss
I
cage?
kind of
If you
wanted to
upload this
distract
video,
Mr.
you're gonna
Obedi.
tell people about your personal lives because it's
Sorry.
I
Man.
take it.
Hi, guys.
And here, it's my name tag pretty much.
Follow me on
Stop the
Instagram.
recording.
Now we have you on video saying that so we can tell your mom and dad.
We can